Okay, today to bring you a case of ultrasonic hardness tester stock user workpiece. There are 4 user-provided artifacts. It has a coating on that surface. The plating is made of die-cast aluminum alloy. Its approximate coating thickness is between 15 and 20 meters. And then the user has to measure. Like the first big piece of wood, just measure this hardness on the outside of its surface. Like these 3. All 3 workpieces have a hole in the surface. There's a deep hole here, to measure the hardness of the innermost plane of the hole. Well, this hardness tester we commonly use, it's like a drop, desktop, like a drop in a cloth. It has very deep tooth marks. This 15 to 20 meters of plating will definitely penetrate. Also, in our book, there is a commonly used inside hardness tester. It uses an impact body to impact the dorsal side. Its strength is also relatively large. Will also punch through the plating, so it can be like. The cloth is a drop type. Follow the director to measure this thin coating. That would be inappropriate. Then it is necessary to select the one with small delay force. Like this Wechsler hardness tester. And then the ultrasonic hardness tester is also a kind of Wechsler hardness tester. The Vickers pressure it uses is a way type girl. Therefore, the ultrasonic hardness tester is accurately a handheld Vickers hardness tester. But why not choose a dimensional desktop? Like the hole we just showed you. This hole is very deep. It's about 4 to 5 centimeters deep. Then the girth indenter we commonly use is not as deep as the bottom side of it. Therefore, the enclosed desktop cannot be measured. At this time, we will choose our ultrasonic hardness tester. But when the ultrasonic hardness tester measures the workpiece of the special material provided by the user, calibration is required. We have a little calibration with a multi-point calibration. Here, the user's price is the same material, and the same kind of heat treatment, the same processing method, its modulus of elasticity is consistent. At this time, just choose the most convenient point for calibration. First of all, we take this artifact. You can see that the position of this work frame is very flat and smooth. This position can be measured using a perimeter desktop. What about us? Today, I measured this position with a perimeter desktop. Its hardness, is 128. Then the test force used is 1 kilogram. Make it a little smaller indentation. Also not to hit through this coating. So we'll start the operation now. Use this plane and circumference to calibrate. After doing a little calibration, measure all the functions of the user. Menu materials. Add a little calibration material. Attention should be paid at this time. After using a little calibration, can only be measured as test paper, that is, HV cannot be measured. Conversion tables cannot be used to measure HRC, HRB, HB. Any other hardness system is not possible, because our conversion table is only for bars. Like other materials, after you get through a little calibration, you are equivalent. Hold the conversion table of cast steel to convert other elastic modulus materials. This is obviously not right. So this time to be special is to pay special attention to a little. Calibration can only use dimensional test paper. You can only test this micro test paper to start slowly. On this plane, we measure it 5 times. It can be seen that the average of 5 times is 756. Then we adjusted 756 to 128 through the up, down, left and right keys. The left and right keys walk 10 fingers at a time. The up and down keys go 1 value at a time. Then there are the left plus right minus up plus down keys. Okay, after we transferred to 128, according to the confirmation, we can see that we have adjusted the value of 75,666 to 128. What about my calibration curve? According to my factory curve, I made corresponding adjustments. And then keep pulling out. You can see that the calibration file in the upper left corner has changed, became MAT04. This is the calibration we just added. After that, we will measure these spaces. 103. 126. 103. And then to test this kind. Let's borrow a hole. You can see that our supermarket does not reflect the first probe. It's easy to get into this hole, and you can touch the bottom of this hole. Yow 84. Yow 87. 8. Talk about Sanhu. 4. Yup. What? Yow 20. 2, 3. You can see that this measured value is still very stable. Well, in this way, we will pass one of them. Through one of them, which is known to be hard, do a little calibration through this face. After doing a little calibration of this material die-cast aluminum alloy, we can measure the hardness of any arbitrary hardness of this pressed aluminum alloy material. That one is like